Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello and welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Now, at the beginning of the summer of 2023, I uploaded a video to Wi-Fi Sheep Channel 2 where I visited Harper Adams University. If you're not aware, we have an additional channel, Wi-Fi Sheep Channel 2, which caters for the extra kind of stuff that I do, sort of outside the general scope of the main YouTube channel. Anyway, if you haven't seen that video, do go and check it out. The link to it should be in the corner of this video. It's also in the events playlist on the main channel. And of course, you can go to 2.wifisheep.co.uk. During the visit to Harper Adams University, I was shown a number of really cool things in the engineering department, including the self-driving hands-free Hector tractor, and that was a load of fun. And also I sat in with some master degree students and we did a basic course in robotics and electronics, including an introduction to the university's own internal robotic buggies called the Atlas class robots. Little did I know off the back of that video that I would actually end up during this summer of 2023 being actually employed at the university. In fact, I now have my staff ID card here. And I'm actually now working for the engineering department. It turns out a lot of what they do there is very compatible with the kind of stuff I do here at Wi-Fi Sheep. So it was an exciting opportunity and I'm really excited to start work directly for Harper Adams University. Now, normally I wouldn't cross the lines between what we do here at Wi-Fi Sheep and the kind of jobs and work I do separately. But there is a lot of crossover and I have been given a couple of interesting projects to be doing over the summer on behalf of Harper Adams. And one of them has actually been to do some work with the Atlas class robots. And I actually have, if I'm bringing it in camera, I have one here. So this is exactly the type of Arduino powered robotic vehicle or driving chassis that the university has. And these are custom bespoke designed by the engineering department at Harper Adams University. So this particular model or unit is called Calypso. It has an ID, let me show you that. It has an ID name on top and it's built on a stock remote control, off-road remote control chassis. It then has a custom PCB here on top and there's a number of sensors, GPS tracking, motion sensors, tracking sensors, and various other expandable I/O. If I show you the top view, you can see it's mainly powered by something that looks vaguely familiar. And it is actually an Arduino, be it a clone, Arduino Mega 2560, which is exactly the same board that we're using for our Project Rio Tiny Basic computers. So already I felt very much at home with these units. So this unit has been with me all summer and I've been doing a little bit of work because I've been tasked to look at redesigning the PCB to do away with the need for a separate Arduino board and actually have all the main chips, including the Atmega AVR 2560, actually inbuilt onto a new custom PCB. And if it's one thing I do know, it is PCBs. So I've actually been in touch with our friends and partners at PCBWay.com who sponsor the majority of the content here on Wi-Fi Sheep to ask them if they would actually be capable of producing a new custom PCB board over in China for this project. Now, I just want to show you this. If you go over to PCBWay.com and you see the main site here, PCBWay offer a PCB assembly service. And it's quite simple to work. You simply ask for the amount you need, unique part numbers, etc., etc. You can then add the PCB dimensions, the stencil, flexible, etc. And you can get quotes directly through PCBWay. This is going to be critical because my intention to get PCBWay to do the surface mount soldering and also the component sourcing for these new boards. This is the latest design for the replacement PCB for the Atlas class robot. This is what I have been working on. It's still very much a work in progress and we've got some way to go, but using KiCad couldn't be easier. And you can see here I have the main processor we're going to be using, the Atmega 2560, and you're able to manually wire it in, if you like, replacing the need for an actual Arduino style PCB board. This is currently where we're at with the Atlas board, but this will change probably over the course of development in the next few months. And it's this file, which we'll keep in-house at university, that I can then transfer to Gerber format and send over to PCBWay to get quotes. And PCBWay will be able to source all the parts we need from a supplied bill of parts list and be able to solder mount everything that I don't want to solder myself or isn't through-hole. So once again, a huge thank you to PCBWay for their continued support and help with this particular project. If you haven't done so already, do go and check them out and get yourself a free account. It's free to sign up. Just head over to pcbway.com. Details and links are in the description to this video. On this particular unit, which I've been using for testing, it's been great to play with actually. I do have one job I do need to do today, which is I need to put a new display board on this pin header here. So let's just put this board back in before we lose it. There we go. Make sure that's in. So when I first got this unit, it was powering up, and it has a, if I show you on the other camera here, it has a 7-volt lithium battery, which that's the drive motor. Where's the battery? It's hiding. Oh, it's up here. It's hiding in the middle of the chassis, right up here. There's a battery, and that produces 7 volts to feed it. And then at the moment, the Arduino actually uses its onboard voltage regulator to take 7 volts down to 5 volts and create 3.3 volts respectively. Obviously, we'll have to put new logic in and new voltage regulators in order to do that work, because we're not going to have this board anymore. But for today, I need to replace this, which was an LCD display. And what was happening was the original, I think I've got them both in this box here. This came from the parts bin from the university. So this was the original. And for some reason, it just started to short out, which meant it didn't work properly, which was extremely annoying, to be honest with you. So I was given a brand new replacement unit, tasked with fitting this to this unit before it goes back to the university. We are right at the very end of August. The new academic year for students starts September, October. So Calypso here needs to go back to the campus. So what I want to do today in this video is we're just going to fit this brand new display, and it does line up. So what I was told to do, the instruction was just to solder straight through on. So don't bother with a header on this, and to just solder this one straight on. I've got to be honest with you, although I've been given my instructions, I'm a little reluctant to do it. I would far rather put a pin header onto this device, and then means you can take these off if there's another shorting problem. So I guess the question is how I got a piece of pin header that will actually fit this. So in the last display, which looks virtually identical to the one that's developed a fault for some reason, you can see that they didn't quite have the right pins. They just snapped one off to solder on. I've got here, this is my own collection. I bought these various header packets because it's surprising how much pin header you get through, especially doing electronics projects. So sod's law, I won't actually have anything that actually is correct, but let's have a look. So what have we got? And it needs to be, hang on. So this is the stuff we need. It's this stuff here is negative or female header, and that will then pop into the pins. And unfortunately, I don't appear to have a piece long enough. Not in here anyway. And I don't think that you can quite, or can we get two bits together? It normally doesn't like, oh no. Okay. That might be alright. Obviously, let's make sure we put it on the correct way round, otherwise we'll be here all day. That might work. It's not perfect because the gap here is a little bit, there's two sort of plastic pieces as opposed to just the one. But that might just work and it will hold relatively steady. What you can do sometimes, what I like to do is if I'm going to have to turn this over to solder, the pin's on this side, a bit of blue tack. We just pop that sort of in there. Yeah, something like that. Okay, and then I'll fire up the soldering iron and we'll get these pins soldered and that should be ready to go. Okay, so just letting the soldering iron warm up now. Because this is not going to sit particularly well, and it needs to sit this way so I can solder. What I've got is I've just found this file handle, which will be fine. So if I just rest that, roughly balance that on there, that'll make it a little bit more stable for me to be able to solder. I've got my flux, alcohol flux that I like to use, so making sure those pins are straight as they're going to be, we just need to flux the top. Nice thing about alcohol flux is it doesn't need to be cleaned off afterwards, it just evaporates, so it's kind of why I like using it. Let's pop that out of the way. Soldering iron is just about ready, so I've got some solder, single core solder here. Just using a wet sponge just to clean up the nib. There we go. Okay, this should be relatively painless. Because it's two pieces, I just want to make sure I've got it secured. And yeah, that's that. That's done. So let's just check what that looks like. Just remove the blue tack. A little bit of play in it, but it's not too bad. I think that should connect on. Yep, okay. So we can pop that back onto the Atlas robot, Calypso, and that hopefully should be fine. Okay, so let's bring Calypso back in. There we go. And the new display should just clip onto these here. That should be pin for pin correct. If that'll work, let's see. Might need a little bit of persuading. If it does, I've got my pliers ready, so we can just make a couple of small adjustments to the pin header if we need to. Just going to tweak these pins just a little bit. Just to give us a little bit of play on the spacing. There you go. There we go. And that looks good. Okay, that's in. I'll leave the protective screen on. Someone at the uni can take that off when they're ready. I suppose we could do a very quick power test. So, in order to power up, on the side of one of these Atlas robots, there's this connector, and that's the battery, and that puts 7 volts through onto the board. So we connect up, And the main power switch is, I'll just show you, it's just here. I might have to grab this because it's probably going to go. Okay. Not quite sure what we're doing. I'll just turn it off, but you did see the display did work. I do think the battery is a bit low in it, so it may not have enough power to actually move itself, unfortunately, because it hasn't had a charge all summer. But let's just test that one more time for you. And then you can see the display works fine. Bit of a twitch. You see it's actually trying to track from the satellite GPS. So it's got a bearing and it's trying to go back to campus, which is some way off from here. But that's kind of cool. So that repair has worked really, really well. As I mentioned, the libraries that's actually used, so the code that's actually uploaded, it's all written in C. It's all on the Arduino IDE, but it's custom. A lot of it's custom libraries, or off-the-shelf code that's been modified, and it's all bespoke to Harper Adams University. So if you're doing a degree or master's in engineering at the uni, then I'm now part of that department, and these are some of the tools and assets that are used for students to play with, and they're great. Okay, so we've come outside and we're about to go for a test run just to see what happens. It can't get out of here, but it could go and mow down a chicken, I guess. So let's see what happens. Now what it's going to try and do is it will log the GPS coordinates to where it is, and then it will try to drive itself back to the campus. That's quite a few miles away. It's not going to make it. It won't get off the site. But let's see what happens. So we power up. You see that, but okay, press 1 to start, which is here. So it's already twitching. There we go. We're going to hit a tree. Well, okay, that's let's point it that way. And you can see it's making its own decisions due to GPS, and every time it wants to go back over here. Oh. There we go. So yeah, turning around of its own accord. Over the apples. Bang into the apple tree. But yeah, so it has a rough idea of what it's trying to achieve, what it's trying to do. Yeah, they're not sure what to make of it. No, we don't like that at all. They don't know what it is, you see, so they're like, it's not on or anything, but no, we're not. We're looking at it, but we're really not sure. Come on, I want my picture of Calypso the robot and the chickens. Are you all too scared? So I'm thrilled we've actually got that sorted, and that was quite a quick, simple repair, but it's been, as I said, fantastic to have one of these Atlas robots here over the summer. And I really am looking forward to the challenge at Harper Adams University come the start of the new academic year in literally a few days' time, as I'm right at the end of August when I'm recording this, and September is almost among us. If you haven't done so already, please do consider liking and subscribing to us here at Wi-Fi Sheep. Don't forget Wi-Fi Sheep Channel 2. Details for that are in the description of this video, or you can go to 2.wifisheep.co.uk. As ever, thank you so much for your company, and I hope to see you real soon, right here on the channel. Until next time, bye for now.